4 and 5. These lectures were given with the recorded lectures which cover the acid-base chemistry in first part of the chapter 3. Okay. So please review the materials if you couldn't do it yet. Today we'll continue to discuss the organic compound introductory part of the organic compounds too. Okay. 그래서 지난주에 조금 스케줄이 꼬여가지고 제가 출장 일정이 막 뒤바뀌어서 업로드 예정되었던 날짜 조금 쉬프트됐던 점 죄송하고요. 이제 아직 조금 리뷰가 부족하신 분들은 꼭 리뷰를 하시기 바랍니다. 질문 있으신 분들은 저한테 따로 이메일을 주셔도 되고 acid base chemistry 그렇게 어려운 부분은 없었어요. 그렇죠? 근데 좀 헷갈리는 부분이 있다. 저한테 따로 연락을 주셔도 되고 introduction part, organic compound 이제 1, 2, 3 섹션으로 나눠서 진행이 될 텐데 오늘도 간략하게 지난 시간 배웠던 거 좀 리뷰하겠지만 지난 시간에는 주로 nomenclature 관련해서 많이 다뤘어요. 그래서 여러분들이 그건 연습을 하셔야 됩니다. systematic name 관련해서 룰들을 저희가 여러 개 다뤘었죠. 그렇죠? lecture에서 그 룰들을 따라가시면서 연습 문제 많이 풀어보시고 좀 익숙해지셔야 돼요. Okay, so yeah, maybe we can do a little bit of review for the acid-base chemistry. These are presentative organic acid and base we discussed in chapter, I guess, 2, right, in acid-base chemistry. And this is the approximate pK values across, right, the typical compound we discussed. So those species are having pretty acidic site. So you have protonated alcohol, right, OH2 plus moieties, and this protonic site is quite acidic. pK value is less than 0, right, meaning very acid. And protonated carboxylic acid, the carbonyl oxygen site is also quite acidic. And as you know, the hydrogen cation or H3O plus, right, it's protonated water, is also quite strong acid. And typical acid we will discuss. We discussed, right, is the carboxylic acids, pK values around 4 to 5, and you have the protonated amine, its pK values around 10, alcohol, water 15 or 16, right? So you better remember these numbers, the range of pK values at least for this typical organic compounds. Okay. The protonated alcohol and carboxylic acid or water below 0, carboxylic acid 4 to 5, protein amine 10, right? Alcohol and water 15 or 16. And these are pieces that we sold together, I guess, in an acid-base chapter and corresponding slide, right? And you know what is conjugate acid and base, right? It's a paired system, right? Acid in Bronsted already definition, the species giving proton, right? Base is the species accepting the proton, right? So you're giving and accepting proton, that's why the pairing concept has to arise. And you know, conjugate acid, for each of the following, right, you can simply answer, right? Guess we already solved this. You can just put the proton, right, to the basic site. Easy. Okay. So it should be carboxylic acid in neutral form. And you have here the amine, so protonated amine, put the conjugate acid, and here, you know, the protonated carboxylic acid as well. I guess I saw 이거 우리 다 다뤘었던 내용이죠, 그죠? 근데 레코드 파트가 빠졌었나요? 이 부분이? 기억이 나도 잘 안 나는데. Right? And write an equation showing methanol serving as an acid, reacting with amine, right? 뭐 어려운 문제 아니죠, 그죠? 다 하실 수 있을 것 같아요. And also equation showing reacting as a base with HCl. Right? So I'm pretty much sure you guys all can solve this one. Which atom of the following compound is more apt to be protonated, right? So the question is asking you which site is more basic, in other words, right? More willing to accept the proton, more apt to be protonated. That's all same expression, right? And you have alcohol and amine. You should choose between these two. Right? And by intuition, you know amine is more basic, right? So you probably know the answer, but with the pK values of the conjugate acid, you can more quantitatively address this question, right? So you can maybe think about, right, the conjugate acid form for the basic site, right? So if you think about conjugate acid for this alcoholic site, should be the protonated alcohol, right? And you know the pK value of the protonated alcohol is below 0, right? Pretty acidic. Whereas the protonated amine is around 10. And you have the value here and there as well, right? So question is asking you which site is more basic. That means your basic site and its conjugate acid form should be weaker acid, right? Which means having higher pK values. So answer is this site, right? So more acid base 뭐 어디가 더 애시딕한 사이트냐, 베이직한 사이트냐 이런 거 판단하실 때 결국 상대적인 건데, 그렇죠? 이 문제 같은 경우에는 어느 사이트가 더 apt to be protonated, 더 프로토네이션 될 경향이 더 크냐 이거 물어본 거죠, 그렇죠? 그리고 어느 사이트가 더 베이직하냐 이걸 묻는 것이고, 항상 뭐 브론셋 로리 애시드 베이스 개념에서는 잔염기 개념에서는 짝염기를 떠올리시면 되겠죠. 더 강한 산이라면 짝염기가 더 안정한 스피시스일 테고, 그렇죠? 반대인 경우는 반대일 것이고, 이 경우에는 어느 사이트가 더 베이직하냐 그러면은 그 사이트의 corresponding conjugate acid의 acidity를 비교해 보면 되겠죠, 그렇죠? 그래서 corresponding conjugate acid의 acidity가 어디가 더 세냐, 더 센 곳에 conjugate base는 더 basety가 약한 것이고, acidity가 반대로 이제 약한 사이트의 베이스는 높겠죠, 그렇죠? 그렇게 구별하시면 되죠. 이 문제의 경우에 지금 프로토네이드 아민, 아까 테이블에서 외워두시면 좋다고 말씀드렸죠. conjugate acid NH3 플러스 사이트의 pK가 10 정도 되니까 사실 되게 약한 산이라고 저희가 이야기할 수 있죠. 그 짝산이 아주 안정하고 약한 산이기 때문에 짝 염기 NH2 모이어티는 아주 베이직하겠죠. So more apt to be protonated 된다. Right, which is stronger base, right? Acetate versus formate, right? And pK is given, so we can answer the questions as well. 좀 같은 문제죠. 베이스에 지금 베이시티를 비교하라고 했으니 conjugate acid의 acidity를 비교하면 되겠죠. conjugate acid의 acidity가 낮을수록 반대 짝염기는 더 강한 염기겠죠. 그래서 지금 acetate와 formate를 비교하는 건데 conjugate acid인 acetic acid와 formic acid의 pK가 주어졌죠. formic acid가 더 강한 산이니, 그죠? 3.8이니까 더 강한 산이잖아요. 그러니까 짝 염기는 더 약한 베이스겠죠. 반대로 acetate가 더 강한 염기겠죠. 그렇게 구별하시면 되겠습니다. Okay. Estimate pK values of the following compounds, and I'm pretty sure you can do that, right? And also you can do that. You can solve this problems as well using the pK values. Rank the following species in order from strongest base to weakest base, right? So you can refer to the pK values of the corresponding conjugate acid, right? And make the order from weakest acid to the strongest acid. That will give you the order you want. 그렇죠? 마찬가지로 strongest base부터 weakest base를 이제 오더링 하라고 했으니 반대로 conjugate acid가 약한 산으로부터 강한 산까지 오더링을 하면 되겠죠. 그렇죠? 약한 산은 pK 밸류가 크겠죠. 강한 산은 pK 밸류가 그러면 이제 conjugate acid가 어떤 스피시스인지 아이덴티파이 하는 건 쉽잖아요. 그렇죠? 프로토네이드 아민이 되겠고 첫 번째 스피시스는 그냥 아민이 될 것이고 프로토네이드 알코올이 될 것이고 뉴트럴 알코올이 될 것이고 뉴트럴 카복실릭 애시드가 될 것이고 그럼 각각에 해당되는 pK 밸류 리퍼링 한 다음에 어느 게 더 약한 산이냐 어느 게 더 강한 산이냐 그 순서대로 오더링 하면 되겠죠. Okay, so again, you should be able to identify the conjugate acid for a given conjugate base, and referring to the pK values for each species, and you can make the order. Okay, so easy one. All right, that's what we discussed for the acid-base chemistry, and we also discussed like stability of A- species, right? Conjugate base. So if right a given maybe I can write down here. So, because this is the general formula for a given acid, provide proton, right? And if you are discussing about right this acidity of this HA species, you need to think about the stability of A- species conjugate base, and we discussed several factors that contribute the stability of A- species, right? So you should review what was that, right? What we discussed in this chapter. So 결국 산염기 반응이 유기화학 저희 수업 lecture에서 다루는 첫 어떻게 보면 반응이었어요, 그렇죠? 그래서 뭐 산도를 비교하는 데 있어서 결국 산의 구조 혹은 컨주게이트 베이스의 구조가 어떤 영향을 미치는지를 저희가 공부를 했었던 겁니다. 그래서 레조넌스 효과, 하이브리다이제이션 효과, 인덕티브 효과 그거를 다 레코드 렉처에서 다뤘었으니까 그것이 결국 A-가 어떤 구조를 가질 때 A-가 스테이블해져서 그게 짝산인 HA가 더 강한 산이 되는지 약한 산이 되는지 그 디스커션, 그 컨텍스트 아래에서 저희가 디스커션을 했었던 거예요. 그래서 무슨 말 하는지 아직 잘 모르시는 분들은 리뷰를 꼭 하시기 바랍니다. Okay. Right, and for the record lecture 5, we deal with the introductory part of the organic compound, right? And we start by asking, right, what is the meaning for you know the organic compound, right? What do you mean by knowing the organic compound, right? You need to call out them. Okay? You need to know their name, especially the systematic name is quite important. And systematic name and structure of their given organic compound. Name and structure, they are very strongly coupled. Okay? So the fact that you know the organic compound, that means you know the structure. Right? So structure information, also very important, right? And we'll discuss right the isomers in the next chapter, but we'll study in this chapter the structure constitution we already studied, right, in the record lecture 5, and perhaps next lecture we'll discuss the conformation, conformal, what is the conformation state for a given organic compound, and then we'll also discuss right the physical structure, and physical structure or physical properties of a given organic compound is also largely coupled with the structure, right? And also we'll discuss the stereochemistry of the organic compound, right? Configuration or geometry of structure, how the structure given in 3D space, right? That's all what we will discuss in the OChem course, the OChem 1, right? And these are a range of the functionalities or functional group or organic compound that we'll study in this course, the OChem. Right? So for each, right, alkene, alkyl halide, ether, alcohol, amine, alkene, alkyne, you need to know how to call out, how to name them based upon their structure. You need to know their constitution, conformation, configuration, right? And then later on, you will learn how they react, right? We will discuss the reaction pattern for a given organic compound. In other words, you'll be able to right, predict how these compounds can be synthesized. Right? So if you know all this, right, name of the compound, structural information, physical properties, and reactivities, then you can say you know the given organic compound, right? Okay, so we'll discuss all about that with this given class of the compound, arcane, alkyl, ether, alkylamine, alkyne. Okay. 그래서 이제 organic chemistry, 이제 organic compound들을 저희가 이제 다루기 시작할 거예요. 챕터에서 본격적으로 이 record lecture에서는 디스커션을 조금 하기는 했지만 리뷰를 드리는 겁니다. 그래서 organic compound를 안다는 것이 무슨 의미인지 일단은 structure를 알아야겠죠. functionality를 알아야 되고 이 structure를 안다라는 것과 그 컴파운드의 이름을 안다는 것은 아주 강하게 연결이 되어 있어요. 컴파운드의 이름을 부르는 방법이 주어진 컴파운드의 스트럭처에 근거하기 때문입니다. 그래서 여러분이 이 컴파운드의 이름을 부를 줄 모른다. 그러면은 스트럭처를 잘 모른다라고 이해할 수도 있겠죠. 반대인 경우도 해당될 것이고요. 그래서 이름을 부를 줄 아셔야 돼요. 그래서 명령법 왜 해야 되냐, 왜 공부해야 되냐 그렇게 생각을 하실 수도 있는데 스트럭처에 근거한 방법이기 때문에 아셔야 됩니다. 그래서 이름을 부를 줄 알면 스트럭처를 아신다는 이야기고 스트럭처 관련해서도 이제 constitution 있고 conformation 있고 configuration이라는 용어가 등장할 거예요. 그래서 이제 뒤에서 더 구체적으로 다루겠지만 일단 structure라고 이해를 해주시면 되겠습니다. organic compound 본딩이 어떻게 이루어져 있고 어떤 스티리오케미스트리를 가는지 이런 것들에 대해서 저희가 구체적으로 이제 뒤에서 다 다룰 것이고 궁극적으로는 여러분이 이제 아셔야 되는 게 주어진 올게닉 컴파운드들이 어떻게 반응을 하는지 반응성이 패턴이 있습니다. 펑션을 부르다는 패턴이 있고 반응성을 아시면 이제 주어진 컴파운드가 어떻게 합성될 수 있는지 합성 경로도 예측하실 수 있겠죠. 그렇죠? 이런 것들이 이제 다 이런 것들을 다 알게 되시면 이제 주어진 올게닉 컴파운드, 올게닉 케미스트리를 완전히 이해했다라고 이야기할 수가 있겠죠. 그렇죠? 오캠2에서도 마찬가지예요. 대신에 이제 클래스가 더 확장되고 다음 클래스를 넘어가는 것뿐이지 이 로직을 가지고 올게닉 케미스트리를 다 공부하시게 될 겁니다. Okay. So that is the structure of what we'll cover. Okay? So nomenclature, structure information, and reactivities of a given organic compound. Right? That's what we'll cover for Chem 1 course. And I guess this is the piece that maybe we didn't solve the record lectures, so maybe we can try just for reviewing what we just learned in the previous lecture. Right? So maybe you guys can try. The problem 4, draw the structure and give the systematic name of a compound with the molecular formula. Carbon 5, hydrogen 12, that has a 1 tertiary carbon, B, no secondary carbons. 연습해 보실래요 지금? Maybe you guys can try to solve the problem 5 as well. Okay. 7번, 8번도 이어서 하셔도 될 것 같은데 일단 4번. Yeah, let's take a look for the piece of 4, right? One tertiary carbon with C5H12. Guess this should be the correct structure, right? And we have one tertiary carbon here, right? With 1, 2, 3, 4, 5 carbon, right? As a saturated form. We'll learn about the degree of unsaturation in the subsequent chapters. But for now, you can think about whether your compound has a general formula belongs to this, right? CnH2n plus 2. If that is the case, then your compound, your organic compound, right? The hydrocarbon is fully saturated. Right? But if you have a ring structure, right, then your Du will increase, right? Degree of unsaturation increase by 1, right? As the number of hydrogen decreased by 2. And that Du can also correspond to the number of double bond, right? If you have, maybe one double bond, then the number of hydrogen will decrease by 2 as well. And this is the case when Du goes to 1. This is C5H12. It follows the same formula, CnH2n plus 2, so there's no degree of saturation. So you are dealing with the saturated hydrocarbon in this case, right? So 유기화학 좀 고등학교 때 미리 공부하신 학생들은 아마 아실 거예요. degree of unsaturation, 불포화도라고 하는 걸 계산을 하죠. 그렇죠? 불포화도가 이제 1에 해당되는 것이 ring structure가 하나 있을 때, 더블 본드가 하나 있을 때, 이제 불포화도가 1에 해당되게 됩니다. 불포화도가 2가 되면 이제 조합이 늘어나게 되겠죠. 링 하나에 더블 본드 하나 있거나, 아니면 트리플 본드가 하나 있거나, 그렇죠? 아니면 더블 본드가 2개 있거나. 그래서 DU와 관련된 이야기는 저희가 또 다른 펑셔널티 이야기할 때 이야기하겠지만, general formula C5HCE로 이제 나왔다, 12로 나왔다. 그러면 이제 saturated case에 해당되니까 여러분들 이제 structure를 그냥 카본과 카본을 이으시고 카본의 남은 사이트는 하이드로젠으로 saturation 되어 있다. 이렇게 생각하시면 되겠죠. 그렇죠? DU 관련해서 또 이제 할라이드가 하나 붙어 있는 게 밑에 problem 5에서 다루고 있죠. 할라이드는 하이드로젠과 똑같다라고 생각하시면 됩니다. DU로 계산되어 있어서 결합을 하나밖에 못 갔잖아요. 그러니까 하이드로젠은 똑같아요. 그래서 이 경우에는 그러면 C4H10이라고 생각하시면 되겠죠. 그렇죠? So if you think about the way in which the halide making a bond, it is actually same as hydrogens making a bond with carbon. So Du, degree of unsaturation in this case, if you want to calculate Du, you can treat this halide as a hydrogen, right? Then you can translate this into your C4H10. It still belongs to CnH2n plus 2 formula, right? Which means Du is 0 in this case. It's fully saturated. There is no degree of unsaturation. So you can think about this as hydrocarbon, right? Without any ring structure, without any double bond. So under these cases, right? So you can then draw, right? The saturated hydrocarbon, one tertiary carbon. Right? You only have this is a tertiary, right? Carbon. So you can perhaps provide this skeleton, and then since you need 5 carbon, so you can add one more. Right? Then you can double check 1, 2, 3, 4, 5. Right? You have 12 hydrogen, but that structure. And then you can call out, right? This is the butane eventually, right? And you have methyl substitute in 2 positions. So this is going to be 2 methyl butane. So what of the structure without secondary carbon? So your structure shouldn't have any secondary carbon. So I guess this is only one possibilities, right? In this structure, you have 4 primary carbon and 1 quaternary carbon, right? There's no secondary, right? Then you can make the name. The longest chain possible you can identify is this one, right? The propane, right? That's the paired hydrocarbon. And you have 2,2, right? Dimethyl substituents. Good job. At the bottom one, again, the DU is 0. This is the fully saturated case. And then you can identify all the possibilities, right, for the constitution of isomer. Okay. So I guess 그 말고 더 있나요? I guess this is the only possibilities, right? For possibilities. So you have the butane with 1 bromo group, right? So 1 bromo butane, 2 bromo butane, right? And this is the iso unit, right? Here you build, right? But you need to call out in a systematic way, right? So you can identify the longest chain propane with 1 bromo and 2 methyl, right? And B should come first, then M in methyl, right? Be 1 bromo, 2 methyl propane. You can do the same thing for this one, right? This is still happy with the general formula. This is the longest possible chain is 3 propane, and you have bromo and methyl group, right? In 2 position, right? So it's going to be 2 bromo, 2 methyl propane. 그래서 어렵지 않습니다. 그래서 리뷰 그 nomenclature 그 룰을 한번 리뷰를 해보시고요. 연습 문제를 많이 좀 풀어보시면 될 것 같아요. Okay? And you guys can try to solve this one. It's not a difficult one, so you can try by yourself. And draw the structure for each of the following compounds. So now the systematic name is given, and you have to know like how to draw the structure, right? So why don't we try maybe DEF? Right? Seems like ABC is pretty simple. So try to solve D, E, and F now. Right? Now you can try, right? So you need to see the last line first, right? So this is heptane. So at the end of the day, right, this name will all give you, right, the 7 carbon containing hydrocarbon, right, the straight chain. So heptane means 7, right? So you have 1, 2, 3, 4, 5, 6, 7. Okay. So 제가 skeletal structure 처음에 introduction 해줄 때 요거 실수하시지 말라고 말씀드렸습니다. 이거 채점하다 보면 하나씩 빼먹는 학생들이 되게 많아요. 그래서 내가 진짜 7개 카본 맞게 그린 건지 항상 더블 체크하시기 바랍니다. 햅테인의 경우는 그죠? 점 하나 빼먹어가지고 본드 하나 없어서 카본 하나 없게 그리신 경우 학생들이 10% 나와요. 항상 채점에. 그래서 실수하지 마시기 바랍니다. Okay. So heptane means you have 1, 2, 3, 4, 5, 6, 7, right? Carbon as a parent right, chain, and then you can put the correct position, right, for the substituent. So you have methyl, right, trimethyl at 2, 4, 5 carbon, right? So you can out 1, 2, 3, 4, 5, 6, 7. Have methyl at 2, 4, and 5. You have methyl. You don't have to write methyl like this, just to give you some clarity. I remember writing it down. And then you have one more substituent, right, at 4 position. Right? The 4 outside of the parentheses indicate the location, right, of these substituent attached to. And these substituents are attached to this 4 position. Right? And then you need to know what this means, right? 1 methyl ethyl, right? And this means, right, you have the ethyl group, right, at the 4 position. 1, 2, right? But for the substituent, right, for the branched substituent, which we discussed in the recorded lecture, this carbon has to be 1, right, for this branch substituent all the time, right? And then 1 methyl, that means, right, you have 1 more methyl group here. Okay, that's how you can complete, right, the structure of the branched substituent. 그렇죠? 그래서 이 레코드 렉처를 보시면 괄호 안에 들어가는 포지션과 괄호 밖에 있는 포지션을 구별해서 설명을 드렸을 거예요. 괄호 밖에는 괄호 안에 해당되는 이 브랜치 substituent 전체가 parent hydrocarbon 몇 번 카본에 붙어 있는지를 표현하는 거 괄호 밖에 넘버고, 그렇죠? 괄호 안에 넘버는 이 브랜치 substituent의 structure 정보를 포함하고 있는 거예요. 그렇죠? 그래서 1번이 뭐냐? branched substituent가 딱 달려있는 요 위치가 항상 branch substituent의 넘버 1 카본이라고 말씀드렸습니다. 그렇죠? 그 넘버 1 카본은 main hydrocarbon의 넘버 1 카본하고 다른 거예요. 그렇죠? Right? That was the rule. What about E? This is the octane, right? So at the end of the day, the structure for this will contain 8 carbon containing longest possible straight chain, right? So you can draw 8 carbon, 1, 2, 3, 4, 5, 6, 7, 8. Okay? So don't make the mistake and count correctly, right? Just to make sure you have 8 carbon in this case. Okay? 1, 2, 3, 4, 5, 6, 7, 8. Okay? And then you can identify the substituent. You have methyl at 2 and 5. 2, 5. You have methyl here and there. Okay? 1, 2, 3, 4, 5. Okay? And then at the 4 position, you have the propyl group. Okay? So this is the 4, and this is a propyl. 1, 2, 3. Okay? But you have the methyl group at 2 position. This carbon always number 1 for the substituent, and you have methyl at 2 position. This is the substituent that you want, and this is the skeletal structure you can draw. So, what about the bottom one? This is octane still. You have 1, 2, 3, 4, 5, 6, 7, 8, right? Containing hydrocarbon, the longest possible chain. And then you can identify, right, the substituent. This has only 1 substituent at 4 position. You can identify this as a number 4 carbon. What the ethyl group, right? It's going to be 1, 2. But you have dimethyl group at number 1 carbon, right? So you have methyl, methyl. This should be the answer for the skeletal structure. 그래서 어렵지 않죠? 그래서 룰을 좀 기억을 하시고 연습을 좀 하시면 됩니다. 반대로 스트럭처가 주어졌을 때 반대 프로세스도 하실 줄 알아야 되죠. skeletal structure나 아니면 chemical structure가 주어졌을 때 그거의 이름을 또 call-out을 똑바로 하실 줄 알아야 되죠. So you should be able to do the reverse process as well for the given structure. You need to know how to call out, right? How to call out the systematic name, the IUPAC name in the proper fashion. Okay, so you should practice. Right. So that's what we covered. I guess the recorded lectures last week, and today we'll keep discussing the organic compound, and today we'll focus on alcohol and amine, and we'll learn right how to call out them. There are nomenclatures for alcohols and amines as well. The yellow highlighted one is what we already covered the recorded lectures, and the blue highlighted one is what we are going to cover for today's lectures. Right? And then we'll discuss the structural information, structural constitution, and physical properties of the alcohols and amines as well. Right? Time allowed. And that's the scope for today's lectures. And next lecture, we'll learn about the conformation, or conformers in short. Okay? 그래서 오늘은 알코올, 아민 관련해서 이제 nomenclature 다루고요. 시간이 되면 뭐 physical property까지 다뤄보도록 하겠습니다. 복잡한 내용은 없고 다 어디서 한 번쯤 공부하셨을 내용인데 원 코र्स 내에서 한번 리뷰를 하신다라고 생각을 하시면 되겠고요. nomenclature 관련해서 이제 새롭게 배우시는 분도 있을 텐데 기본적으로 뭐 비슷한 룰을 따르게 됩니다. 알케할라이드 이더에서 저희가 다뤘던 nomenclature 방법론과 거의 유사한데 이제 알코올 아민에서 약간의 특이성이 존재합니다. 그 부분을 오늘 공부하시면 될 것 같습니다. Okay? Right, so nomenclature of alcohol. Right, this is general formula for alcohol as you know, the alkyl group and hydroxyl moieties. So alcohol is a compound in which the hydrogen of alkane, right, one hydrogen, is replaced by an OH group. Right? And then you can classify primary, secondary, and tertiary alcohol. Right? You are seeing here the carbon attached to the hydroxyl group. Right? And if that carbon has only one alkyl group, then we can call it out as a primary alcohol. Okay? But if the carbon attached to this hydroxyl group has two CC bond, or bonding with two alkyl group, in other words, you can call out this is a secondary alcohol. Okay? And you can extend this idea. If the carbon attached to the hydroxyl group has three alkyl group, in other words, having three carbon-carbon bond with the surrounding alkyl group, then we can call out this a tertiary alcohol. Okay? Primary, secondary, tertiary 개념은 반드시 잘 알고 계셔야 됩니다. 어려울 거 사실 없죠. 카본이 주변에 다른 카본과 본딩이 몇 개 있냐, 한 개 있냐, 두 개 있냐, 세 개 있냐, 그거 가지고 저희가 primary, secondary, tertiary로 나눈다라고 이야기했었습니다. Right, that's the definition for primary, secondary, and tertiary alcohol. Again, you need to be able to count, right, the number of carbon or alkyl species, right, attached to the carbon of interest. Okay, and these are common names. Common name for alcohol. This is not systematic name, right? You need to distinguish common versus systematic name. Right? Common name is given by convention, right? Systematic name is given by the structural definition. Okay, so common name은 쉽게 말해서 관용적으로 저희가 이름을 불렀던 방식이라고 이야기하시면 되고요. 일정의 룰이 있습니다. 근데 룰이 뭐 일정 룰은 있으나 예외가 꽤 있어요. Systematic name은 저희가 structure에 근거해서 문법적으로 사용하는 이름이고 여러분들에게 시험 때 물어보는 거는 common name이 아니라 systematic name이겠죠. 그렇죠? common name을 뭐 아셔서 나쁠 거는 없겠죠. 관용적으로 어떻게 불러왔는지 스피시스에 대해서. 그래서 관용적으로 불리는 common name 관련해서는 이게 항상 룰이 이거 아닙니까? 라고 저한테 질문하실 수가 있는데 때때로 예외가 항상 있어요. 그래서 좀 암기를 하셔야 되는 요소도 중간중간 좀 있습니다. systematic name과 비교했을 때. Okay, so this is a common name for alcohol, so you should call out the name of alkyl and then put the alcohol at the end. Right? So you have ethyl group here and an OH group at the end. Right? So you can make ethyl alcohol for the ethanol. Right? For this one, you have propyl, right? The alkyl moieties with the OH group. So you can make the propyl alcohol for the common name. Again, common name is given by some convention, and there are some rules, but sometimes there's some exception. Right? This is a very basic one. And you have, right, this unit, structure unit, which we discussed in the recorded lecture. This is the isopropyl unit. Right? That's why you can make the common name here, the isopropyl alcohol. This is iso. As we learned, this is a common name, right, for this moieties. And you have here another iso unit, but with one additional carbon, right? And this unit is called isobutyl. Right? You have iso unit with one more carbon, right? And this carbon is primary. Right? So that's why you can call out this entire moieties as an isobutyl and put alcohol at the end. 아이소프로필과 아이소뷰틸 모이티에 대해서 지난 레코드 렉처에서 다뤘을 거고요. 그렇죠? 아이소뷰틸인 경우에는 이제 attach되는 부분의 카본이 primary position인데 이제 secondary 카본으로 주어지는 경우도 있죠. 그리고 저희가 secbutyl 또 공부했었습니다. Right, what about systematic name? These are the system for systematic name. Okay? And IUPAC system, right? That's the system that you need to know. So according to the IUPAC system, right? The IUPAC system use suffix, right? Suffix means the moieties, structural moieties putting at the end, right? And the unit name to designate or to denote the functionalities or functional groups, right? The functional group of alcohol, of course, is a hydroxyl moieties, hydroxyl group, which can be denoted by OL. That's the suffix, right, for alcohol. So you should make the name, this is my name of the alcohol as an O at the end, right? So you have here the methane moieties with hydroxyl, right? So this is going to be methanol in systematic name or IUPAC name in other words. And you have ethane moieties with alcohol, the hydroxyl moieties. So this is going to be ethanol. So you can identify the parent hydrocarbon, right? And put the OL at the end. You can just switch E, right? With OL. So if you think about methane, right, the arcane, it ends with E, right? You can switch E with OL. That will give you the systematic name for alcohol. Okay? What about this one? Right? This is going to be the pentanol, right? With the 3 position. Right? And then you should specify the locality, the location of the OH group attached to at 3 carbon, right? So this can be a 3 pentanol, right? Again, you switch the E with OL, right? So without alcohol, this is supposed to be the pentane, but you switch the E with OL, so it's going to be pentanol, but you should specify the location where OH just attached to. But you can sometimes write down in this way too, right? In between N and the OL, can specify the location, the locality of the alcohol, the hydroxyl group, with the hyphen right in between. Okay, what about this one? These two are also equally possible, right? You have 1, 2, 3, 4, 5, 6 carbon. So, so this to be a hexane, but with the alcohol, the hydroxyl group, this is going to be hexanol. Okay? But you should specify the location, right? The OH group, the carbon attached to OH group, needs to be number 1 carbon, and then this carbon must be number 3 carbon. And then you can make 3 hyphen methyl, right? To specify this methyl moieties. And then there's 2 possibilities, right? You can make hyphen with 1 hyphen hectanol, or you can write down, just put together 3 methyl hexane and specify the 1 in between N and O, right? O of OL, what the hyphen in between. Right? So these 2 are equally possible. Right? The number precede the name of the parent hydrocarbon, hexanol in this case, that's fine. Or the number can precede the suffix OL, that's also equally possible. 그래서 이 2가지를 혼용해서 쓰는데 상관없다. Name of the parent hydrocarbon, 이제 hexane, hexanol 앞에 그 첨가 앞에 1을 붙여도 되고, 혹은 이제 OL suffix 바로 앞에 1을 붙이셔도 됩니다. 그래서 1이 들어가는 순서는 크게 상관이 없다. 이렇게 이해하시면 되겠습니다. Okay? Rules for systematic names. It's all logical, and if you are familiar with the naming system for arcane and arcane halide, pretty sure all the rules covered for alcohol and amine is pretty just extension. So the rule number 1, the parent hydrocarbon is the longest continuous chain containing the functional group. So you should identify the longest possible chain that contain the OH group. Rule number 2, the parent hydrocarbon is numbered in the direction that gives the functional group suffix, right? OH or OL moieties, the lowest possible number. Right? That's important. So when you give the number, you have to make the number so as to make the number attached to your OH group is the lowest possible number. 그래서 OH 그룹이 붙은 카본의 넘버가 가장 작게 배치되게 넘버링을 한다. 이게 이제 중요한 룰이 되겠습니다. 그렇죠? 이 부분을 이제 기억해 주시면 될 것 같아요. 룰 넘버 1은 arcane hydrocarbon chain 넘버링 및 네이밍 할 때 다 다뤘던 내용이고요. 그렇죠? Right? So for instance, for this one, you can identify the longest possible chain. It's a butane here, so it's going to be butanol at the end of the day. But you have the OH group at 2 positions. This is why the species allowed 2 butanol, or as I mentioned in the previous slide, you can call out just butane 2O. Right? You can put the 2 just in front of the suffix or in front of the full chunk right here. The parent hydrocarbon. Okay. What about this one? You can identify the longest possible chain contains this OH. It should be this way. So you have 5 constant carbon, so they're going to be pentanol at the end of the day. And there's a way you can choose a number, right? You should start this one as number 1, so as to make the carbon attached to the OH group as the lowest possible number. That's why you shouldn't pick this one as a number 1, right? And this carbon become number 5, which is not correct, right? So you know number 1 carbon attached to OH group, number 2 carbon attached to ethyl. What is, right? So just put together, you can name 2 ethyl and 1 pentanol, right? So you have ethyl group at 2 carbon and alcohol OH group at 1. Okay. And of course you can use the bottom name as well. Just put number 1 in front of the suffix OL. What about this one? You have ether moieties and alcohol at the same time, but we'll call out this as an alcohol at the end of the day. Okay? The alcohol it has a higher priority. Okay? And then you can identify the longest possible chain, right, that contain the OH group. Right? That's why this is the main chain you should pick. So alcohol has a higher priority than ether. Right? We'll learn about that in the next chapters as well. But for now, you can just accept the alcohol as a higher priority than ether. That's why you should identify the longest possible chain containing the alcohol OL group. Right? So this is going to be propanol at the end of the day. Right? And then these entire moieties is treated as a substituent. Right? And you have 1, 2, 3, 4 butoxy moieties. Right? Butoxy moieties at number 3 carbon, because this carbon has to be number 1 to satisfy rule number 2. So in total, putting all together, you can call out this as a 3 butoxy, 1 propanol, or again, you can write down 3 butoxy, propan, 1 ol as well. So equally fine. 그래서 functional group의 이제 우선순위에 대해서도 나중에 배우시게 될 텐데, 지금 당장은 ether보다 알코올이 functional group priority가 높다. 알코올은 시스테믹 네임에서 알코올로 명명을 하게 되고요. ether는 우리가 지난 시간에 다루긴 했었지만, 그죠? 알케인으로 명명을 하게 됩니다. 그래서 알콕시가 substituent가 돼서 알콕시 알케인으로 명명을 했었죠. 그죠? 기억 안 나시면 리뷰를 하시기 바랍니다. 그래서 알코올이 있는 경우에 이렇게 ether functionality와 알코올이 다 존재하는 경우에 이 스피시스는 결국 시스테믹 네임에서 알코올로 명명을 하게 돼요. 그러면 이제 ether moiety에서 이 파트는 알콕시 substituent를 이제 분류하게 돼서 알콕시 something ol이 되겠죠. 그렇죠? Okay. Rule number 3. Rule number 3, if there are 2 OH groups, then you should use the diol, the suffix diol, right? Which should be added to the name of the paired hydrocarbon. For instance, you have this species, you have 2 alcohol at 2 and 4 positions, right? That's why you can call out this as a 2,4-hexanediol, right? Or you can make this 2,4 in between, right? The hexane and diol as well, as we discussed the previous slide. This one, you have also 2 hydroxy group, and this is the pentane, right? 1, 2, 3, 4, 5. That's the longest possible chain you can identify. Then you have 2, 3 position, right? I call it 2, 3 position, and 4 with methyl, right? So in total, you can make a name like 4 methyl, 2, 3 pentanediol. Or you can locate this 2, 3 in between pentane and diol as well. Okay? Rule number 4, if there is a functional group suffix and a substituent, right, then the functional group suffix get the lowest possible number. 그렇죠? 그래서 이제 이 경우가 substituent와 suffix, functional group suffix가 경쟁을 하게 될 때는 functional group이 이긴다. 그렇죠? So that's the priority. Again, if there's a functional group suffix and substituent we need to call out, then functional group suffix get the lowest possible number. Right? So take an example here. You have halide versus hydroxy group. Right? And this halide is treated as a substituent, right? As we learned in the previous lecture. We were calling this as a substituent, right? Bromo. Right? But the OH, the hydroxy group, makes the name of this as an alcohol, right? O at the end of the day, right? This is a suffix. Suffix and substituents are totally different. Okay? And you need to decide the number, right? This one, 1, 2, 3, or you can make this 1, 2, 3. Yeah, this carbon has to be number 1, right? So as to make, right, the carbon attached to this alcohol, right, get the lowest possible number, right? With which you can identify this carbon as number 3. So that's why you have 3 bromo and 1 propanol for this compound. What about this one? You have chloro, the substituent, versus alcohol, the functionality, the suffix, So you have to make, then you first identify the longest possible chain that contain, right, this OH moieties, right? And then you should decide whether this carbon is 1 or this carbon is 1. The 4 is right, to make the carbon attached to this alcohol, the OH moieties, as lowest possible number, which is 2 in this case. Right? This is going to be 2-butanol at the end of the day, but you have the chloro moieties at 4. So you have 4 chloro and 2-butanol. Right? Again, the halide here is given as a substituent, so you make the halo, right, as a substituent. So bromo, chloro, iodo, right, and fluoro. That's a substituent. Okay. What about this one? You can identify the longest possible chain that contain, right, the functionalities, the alcohol, right? And this is, I guess, easy one. You have the then pentanol, what number 2 carbon here, and 4,4-dimethyl moieties. Rule number 5: if counting in either direction give the same number for the functionalities, the functional group suffix, right? Then the chain should be numbered in a direction that gives a substituent the lowest possible number, right? This could be a rare case, but can arise, of course, right? So if the counting will give you, right, same number for the functional group, then you should think about substitute, right? And choose the direction that give you the lowest possible number for the substituent. 논리적인 흐름이겠죠. substituent와 functional group suffix가 경쟁하게 될 때는 functional group suffix에 손을 들어줘야 되고, functional group suffix가 동치일 때는, 동률일 때는 그 다음 뭐 substituent가 낮은 번호가 되게 넘버링 하는 게 로지컬한 뭐 결론이겠죠, 그죠? 복잡할 건 없겠죠. Right? So that's rule number 5. So maybe you can take an example here. The first one, right? First, you can identify the longest possible chain that contain alcohol, right? This one, right? And you have 1, 2, 3, 4, 5 carbons. So this is going to be pentanol at the end of the day, right? Logically, you can decide this as a number 1, 2, and 3, right? So either way, right, from left to right, right to left, will make this carbon attached to OH group is number 3. This way, you need to make from left to right to make, right, the carbon attached to chloro group as the lowest possible number, which is 2, right? That's why this is 2 chloro, 3 pentanol. Not 4 chloro, 3 pentanol. 그죠? 왼쪽에서 오른쪽으로 넘버링 하는 게 맞겠죠. 왼쪽이든 오른쪽이든 OH 그룹은 가운데 3번에 있으니까 다음에는 이제 클로로 그룹이 붙는 카본의 넘버링이 낮아지는 쪽으로 방향을 선택하시면 됩니다. 그렇죠? What about this one? You have the longest possible chain, right? They contain hydroxyl group. So this one gonna be cyclohexanol at the end of the day. But you can choose, right? You have a direction, right? You can make this way or this way, right? This carbon has to be number 1. If you make, right, counterclockwise, then this carbon can become number 3. But if you make the clockwise, then 2, 3, 4, 5. The methyl attached carbon become 5, right? The 5th carbon, which is not preferable. You should choose the counterclockwise so as to make the substituent attached to at the lowest possible number, which is 3. That's why this is 3-methyl cyclohexanol. Okay. And here's a little side note. There's no need to put a number in a cyclic compound, right? What that means here, this carbon is assumed, right, to be a number 1 carbon, right? So there's no need. You identify the position carbon having an OH group, right? In this case, in the cyclic case. Your ring structure 가지고 있고, cyclic form인 경우에는 number 1 position OH 그룹을 가지고 있는 카본의 넘버를 identify 할 필요가 없다. number 1으로 assume 된다. Rule number 6: if there is more than one substituent, then substituents are listed in alphabetical order. Okay, let's read on. Okay. Substituents should be listed in alphabetical order. So in this case, you have bromo group and ethyl group, right? Then B should come first, then E, right? That's why you put bromo first, then ethyl. Okay. Here you have methyl and yeah, this is not a difficult one. What about this one? You have ethyl, right, and methyl, right? In this case, ethyl should come first because E should come first in alphabet. Okay, then M of methyl. Right, and this is the general structure of naming. Remember that the name of substituent is stated before the name of parent hydrocarbon, right? But the functionality, the function of suffix should be stated after the name of the parent hydrocarbon. So you have here the functionality, the suffix, right, and substituent, and in the middle you have parent hydrocarbon, right? So you should call out substituent first, parent hydrocarbon, followed by the functionalities of the suffix. Right? That's a general structure, general rule for naming the systematic name. Okay. What about amine? Very similar to alcohol. I guess we can perhaps finish the nomenclature for amine. Amine, what is the amine? In general, amine is a compound which one or more hydrogen, right, is replaced by the one or more hydrogen of ammonia, replaced by alkyl group. So starting with ammonia, you can identify here the primary amine, secondary amine, and tertiary amine. Right? The way in which you call out primary, secondary versus tertiary is the number of the alkyl group attached or directly attached to the nitrogen. So you have only one, right, alkyl group. That's why this is the primary amine. In this case, you have two alkyl group. That's why this is secondary amine. And since you have three alkyl group here, that's why this is the tertiary amine. Okay, and this is the common name below. In common fashion, by convention, in other words, you can just call out the alkyl amine, right? Take an example here. You have methyl, right? Alkyl moieties, right? It's going to be the methylamine, and here you have methyl and propyl moieties, right? And M comes first, and then you can make M the methyl propylamine, right? That's a common name. What about this one? You have 2-ethyl, right? That's why you can call out as a diethylamine. In this case, you have trimethyl, right? In this case, you have butyl and dimethyl, right? Amine. In this case, you have ethyl, E come first, right? And then methyl, M come first, and then P of propyl. So in total, ethyl, methyl, propylamine. That's the common name. In systematic way, right? The E at the end of the name of the parent hydrocarbon is replaced by the amine, right? Like you switched E with OL for alcohol, you switch E with amine, amine for amines. Okay. And then number, identify the carbon to which the nitrogen is attached, right? And the number can appear before the name of the parent hydrocarbon or before amine. So what that means, you can take an example here. For example, you have, in this case, the butanamine with number 1 carbon attached to NH2, right? And then you can specify that number in front of the parent carbon or before amine, as you did for alcohol. Right? So these are equally fine. 1 butanamine or butan 1 amine. What about this one? You have the amine with, this is a secondary amine, right? That means you have 2 alkyl moieties centered to the nitrogen. You have this chunk and this ethyl moieties, right? For this amine. In this case, you have to follow the following, right? You have to start with the italic N, right? And identify the first alkyl moieties. Start with E, right? Ethyl, right? And then the next substituent, the second one follows, right? Which is 3, right? Hexane, right? And then you switch E with amine to finalize, right? So at the end, right? So we're going to be italic large N, ethyl 3-hexenamine. Okay? Or you can put the number 3, right? The carbon, the number of carbon, the carbon, the position of carbon attached to the nitrogen side, right? Just in front of AMINE, okay? Like article. What about this one? This is a tertiary amine. That means you have 3 alkyl groups, right, surrounding the central nitrogen. So you have ethyl moieties, methyl moieties, and propyl moieties, right? In this case, you have to identify two alkyl moieties, and then make the arcane amine at the end of the day, right? So this is, you can identify the longest possible chain here, and this carbon must be number 1, right? And you have two alkyl moieties, which is ethyl and methyl, and E should come first, then M of the methyl, right? So large italic N, ethyl, large italic N with methyl. That means you have this ethyl and methyl for this propanamine. Okay? And of course, the number 1 position, the carbon position attached to nitrogen can gear into the central position between hydrocarbon and AMINE. 그래서 생각에는 나머지 룰은 거의 다 비슷한데 다음 시간에 이어서 하면 될 것 같고요. 아미네 같은 경우는 알코올과 다르게 1차, 2차, 3차 아민일 때 알킬 그룹의 이제 개수가 바뀌게 되죠. 그렇죠? 프라이머리 아민인 경우는 그렇게 복잡하지 않으면 세컨더리, 터셔리 아민일 때는 이제 메인 체인에 붙어 있는 알킬 그룹 말고 어디셔널하게 하나 그리고 2개가 더 존재하게 되는 거잖아요. 그렇죠? 그 경우에는 large N, italic N과 함께 스페시파이를 해주시면 돼요. 다음 시간에 이어서 계속하도록 하겠습니다.